Okay, so what we want to do now, we can now do dynamics. We now have everything we need. Right? We have some of the torques as I alpha. Now we know what I is. Now we can do dynamics. Let's do some dynamics. There's a bug. Let's look at the, I don't know what to call it, the light pulley Atwood machine. Remember, an Atwood machine is just two masses hanging off a pulley that accelerates slower than gravity. Okay? And I'm going to go through actually and do it real fast. It's really from like a couple weeks ago. But let's just do it real fast just to remind ourselves how it works. So as a review is what I'm trying to say. So remember we had M1 and it went around a pulley. There's a good way to draw a pulley like that. And we had M2. And it's just an ideal massless pulley. Right? It has no mass. So it really made the problem pretty straightforward. We said, well, M1 is greater than M2. Therefore, it's going to accelerate like that. That's going to accelerate down. That's going to accelerate up. And there's going to be some tension in the rope. And we told you that the tension will be constant. Right? As long as you don't apply a lateral force to a rope, the tension's the same all the way through the rope. And this led to basically two unknowns. And those unknowns were the tension and the acceleration. So this problem usually you would solve for tension and acceleration. And we had two equations. Right? And the two equations were F equals ma1, the force of 1, and the force 2. So we could do it real quick, right? Because good review. Let's do it for review. Remember, you got to get your directions right. Right? Okay, so for mass 1, sum of the forces on 1 equals the mass times the acceleration of 1. So that was tension was up, mg is down, minus m1g is down, equals what? M1 and A, but we make it negative because we're looking for the magnitude of A. Okay, so this is the magnitude of A. That's why I put in the negative. It's best to usually just work in magnitudes and put the negatives in manually. Okay? So if that's just what you would do and you're fine, don't listen to the next 1 minute of talking. Okay? You're exempt from the next minute. But if you worry about negative signs and what I'm talking about, listen. Okay, you ready? You could say, I want to put in the component. I want to call this the vector component of A. Therefore, you make it positive and you let the problem tell you which way it went. Okay? You could want to do that. But if you do that, then you can't just say they're the same. Because if you do that, then they're going to come out in different directions. So then you got to call this A1 and you got to call this A2. Because maybe they're in different directions and the component has to tell you that they're going different directions. So that would suck, because now you have three unknowns. What do you do now? Oh, the into third equation. A1 equals negative A2. So there's your third equation. Okay? So you could do it with components and solve for components, but in most problems it's better just to do magnitudes. So if you just do magnitudes, they have the same magnitude. This rope can't stretch. And you just put in the direction. Another reason to do magnitudes and manually put in the direction is whenever you're dealing with mg, you don't usually want to say, I'll consider g a component and I'll let the problem tell me it's negative. You know it's negative, right? And you know we mean g means positive 9.8, so you put in the negative. Okay, so most problems it's better to go for the magnitude and put the negatives in. Some problems you don't know which way it's going to go. If you're really lost, and I don't know if it's going to go up or down, I can't tell. This way is more, maybe it'll go that way. Yeah, then you got to do the components, I guess, to let the problem tell you. Okay, okay, now you can listen again if you weren't into that. Okay. So if we, okay, so we don't want to do the algebra here, but we had t minus m1g equals minus m1a, and here we had, for this one, it would be t minus m2g equals, and this one would be plus, because we know this one goes up, plus m2a. Two equations, two unknowns. Unknown, 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 unknown. And when you solve it, you get the answer for the simple thing is that A is m1 minus m2 over m1 plus m2g. So the Atwood machine does what it's supposed to do. It lowers the acceleration. If these two are almost the same mass, this number is small over this number that's big, slows it way down. If m1 weighs a lot more than m2, it doesn't slow it down much, right? So this number minus this number is almost as big as that. It falls at almost g. Okay, okay, so after the break, we will do the Atwood machine with a massive pulley. If you can wait. Can you all wait, or do we need to do it? You can wait 5 minutes because I know you're excited. Okay, let's wait 5 minutes.